This video is for the verifying theorems, intersecting lines, and line segment notes. This is also for lesson 3.3. So we're going to start with the transformational method. All right, given line segment AB intersects line segment CD at point E, verify that angle 2 is congruent to angle 4. So we're trying to prove that angle 2 is congruent to angle 4. So option 1 is our patty paper that we've been using. So we can use patty paper to trace angle 1, and again we want to make sure that we're getting that vertex, and then we can transform it and line it up with angle 4 to confirm that they're the same size. Option 2 is you can fold the paper so that angle 2 is reflected on top of angle 4. So in that case, we would copy both the angles and we would fold, okay, we would fold across this way to see if they line up, to see if they're a reflection. Okay, so we can either rotate using the patty paper or use reflections. So what type of angles are angle 2 and 4? These are vertical angles. Okay, so now we're going to use the coordinate method. So given line segment AB intersects line segment CD at point E, verify that angle 2, so here's angle 2, is congruent to angle 4. So using the coordinates of points A, B, C, and D on the coordinate grid, determine the length of the sides of triangle AED and BEC. So let's see, point E is at 7, 6. Okay, what we could do is we could use the distance formula, okay, which is x squared minus x1, x2 minus x1, squared, plus y2 minus y1 squared. Okay, so point A is at 6, 10. B is at 8, 2. D is at 12, 10, and then C is at 2, 2. So I'm only going to do a couple of these. So A to E, and here's point E. If I did distance formula, so my x's are 7 and 6, so 7 minus 6, and then my y's, I have to start with this y, 6 and 10, so 6 minus 10 squared. Remember when we do the distance formula, we do just what's underneath that radical because we don't want decimals. And so we get 17, which means AE would be the square root of 17. And you could go through and you could do this distance formula for each side. So I'm going to go ahead, I'm just going to tell you what they're going to be because it would take us forever to type all of those out. This one would be the square root of 41. This one would be the square root of 41. And then this is 6, and this is 6. And again, that's just using distance formula. So we could use the lengths of the sides to show corresponding angles are proportional, and therefore triangles are similar by the SSS similarity. Each triangle, so this triangle up on top and this triangle on bottom, all three sides measure the same, which means all three angles have to measure the same. So since the triangles are similar, corresponding angles are congruent. That's a whole lot of work, okay? All right, given line segment AB intersects line segment CD at point E, verify that 2 is congruent to 4. So same deal, new method. So the method for this one is going to be the axiomatic method. We could work our way through all these pairs. So angle 2 and 3 form a linear pair, therefore they're supplementary. So measure of angle 2 and the measure of angle 3 are going to equal 180 degrees together if we add them together. 3 and 4 are a linear pair, therefore they are supplementary. Angle 3 and angle 4 together would add up to 180 degrees. And then using the substitution property of equality, set the two equations equal to each other. So the measure of angle 2 plus the measure of angle 3 would be equal to the measure of angle 3 plus the measure of angle 4. See how we've got the 3 on both sides here? So using the subtraction property of equality, subtract measure of angle 3 from both sides of the equation. And all we're left with is the measure of angle 2 equals the measure of angle 4. If we subtract the measure of angle 3 from both sides, those two angles are now equal to each other. So therefore angle 2 is congruent to angle 4. I personally would use the patty paper method. So that's it for this set of notes.